Okay, this is a revision on electrolysis for our AQA trilogy, and we need to know that electrolysis is the splitting of an ionic compound. And you can see in this diagram here with the ions, you've got plus and minus ions which will be present in an ionic compound because of the electrostatic charges, opposites attracting in an ionic compound. So in, for example, sodium chloride, you can see here, which we know is salt, you can see that it forms what we call a crystal structure, a crystal lattice formed of sodium plus and Cl minus ions. And as a revision, you will hopefully remember that sodium forms positive ions because it loses an electron, one electron, so therefore a +1, and chlorine forms a negative chloride ion because it gains an electron and it therefore has more electrons than protons, so overall it's negative. So we have an ionic compound and we can split this in two ways. We are able to split this up so that the electricity can take its effect by either melting it or dissolving it. Melting, as you can see there on the left, needs 800 degrees C, for example, for sodium chloride, and that's a lot of energy. And a way of doing it that's easier is to dissolve it, which you can do at room temperature. And what happens is the water gets in between the plus and minuses and allows them to separate. Okay, so if we were to take a molten ionic compound like sodium chloride, we can see here this is our electrolysis chamber. We've got a positive anode which will attract negative ions, and we have a negative cathode which will attract positive ions. And so if this was sodium chloride, we would have sodium and chlorine, and they would, the positive sodiums would go to the negative electrode, and the negative chloride would go to the positive electrode. That means that in a molten ionic compound, it's very simple. There's only two ions. Here, sodium and chlorine, for example, and that means that at the positive electrode, chlorine gas is going to come off, and at the negative electrode, sodium metal is going to come off. Now, the complication comes when we dissolve something, and that's because if we look here, we can see that water actually breaks up into two types of ions itself. So if you dissolve something, you add water to it and mix it, you have also got H plus ions and OH minus ions. So if at the bottom here you look, you can see that our sodium chloride dissolved in water has Na plus and Cl minus, just like before, but also H plus and OH minus from the water. And so if we put this in our electrolysis chamber, you can see that we've got our positive and negative electrodes, and it means that the OH minus and the Cl minus are going to go to the positive, and the Na plus and the H plus are going to go to the negative electrode.
Do you want me to wait outside a minute?
And so when that happens, we have to decide what's actually going to come off. Because remember, when it was molten, it was simply a case of sodium at the negative electrode and chlorine at the positive electrode. But now we've got a choice, and so we need to know which rules. So let's take the negative electrode. Sodium and hydrogen would go to the negative electrode because they're both positively charged. But the rule is, it is the least reactive that will come off. And so here you can see that hydrogen will come off. And in this case, we need to say what the ionic equation will be, and we call this a half equation. And you can see here that at the bottom, we've got 2H plus 2E minus goes to H2. Now, the half equation is the formation of an ion in reverse, and you may remember me doing that silly dance. So how did hydrogen become a hydrogen ion? Well, it lost an electron. So to go back to an atom, it needs to gain an electron. So H plus E minus will go to H. But because hydrogen goes around as a gas, H2, you need two hydrogens and two electrons, and that's balanced. Okay, so the half equation at the negative electrode for hydrogen coming off is 2H plus 2E minus goes to H2. And that's always going to be the case for if hydrogen comes off. Okay. The only time hydrogen won't come off is if there's a metal that's less reactive than hydrogen. So for example, silver or copper or tin or gold. Now, what happens at the positive electrode? Well, in the example we gave where we had chlorine, Cl- ions and OH- ions, the two negative ions are Cl- and OH-, so they both go to the positive electrode. You can see them here. Well, which comes off? Well, that's the other rule in a dissolved solution, and that is, at the positive electrode, if there is a halogen, which is a group 7 element, chlorine, bromine, iodine, then that will come off. And you can see here at the bottom, Cl- goes to Cl2, 2 and 2 electrons. Now, this is the formation of chloride ions in reverse. So how did chlorine become an ion? Well, it gained an electron to become Cl-, so this is in reverse. So it's going to lose an electron, and because it goes around as Cl2, we have to balance it. But you can see that because it's lost an electron, the electron whizzes off, so you end up with 2 Cl- going to Cl2 and 2 electrons. So our rule for the positive electrode is if it isn't group 7, it will come off. But what happens if there's no group 7? So you can see here we have got a NO3- ion and the OH- ion. And in this case, if it's not in group 7, oxygen comes off. And this we can learn. If there's not in group 7, oxygen comes off means that it's always 4 OH- goes to 2 H2O plus O2 plus 4E-. Okay, that is the half equation of the positive electrode, which we can learn. Okay, so in our electrolysis of a molten solution, a molten ionic compound is just 2 ions, which makes it easy. If it's in solution, we need to bring in the rules. Negative electrode, the least reactive. Positive electrode is the group 7, or if there's no group 7, oxygen. Now the last thing to say about electrolysis is this: we need to bring in oxidation and reduction. And so oil rig, oxidation is loss, reduction is gain. When sodium, for example, or hydrogen goes to the negative electrode, it's going to get back the electron it lost to become an ion. So it's going to gain electrons. And oil rig, reduction is gain. It means that positive ions are reduced. Chlorine became an ion by gaining an electron. When it goes back to an atom, it's going to lose an electron, and so the oxidation is loss comes in. And so anything going to the positive electrode, either a group 7 or oxygen, has been oxidized. And it really is that simple. You can know that at the negative electrode, something is going to be reduced, and at the positive electrode, it's going to be oxidized. And so that is a summary of electrolysis of a molten ionic compound. It's always an ionic compound. A aqueous ionic compound with the rules attached, and also oxidation and reduction.